Presentation was called Innovate, Validate, and Elevate, which is almost in direct contrast of what you just heard. So this is going to be a fun little drive. So this is what I'm calling our LabVIEW quality paradigm. And once I get the slides going here, there we are. To drive innovation in cutting-edge solutions, which is why we're all here, we try to employ vigorous validation and ensure continuously elevating code quality. And the reason we do that is to ensure excellence and reliability in every project. And that's going to vary on every project, right, with different perspectives. So I'm going to try to go at a relatively accelerated pace, much like you saw Darren yesterday, if I can keep up. So take notes, take pictures. I love Jim Carrey. And there is still tea and coffee in the back if you need that. So please hold on, be prepared to elevate your quality. So what is quality? Is it measured in the quality of work that we do or the safety in which we carry it out? Is it measured in the effort of our quality and our completeness? Some agree, some may not. I know Jeremy Clarkson does not, which I find him hilarious at times. So this presentation is to try to build up your knowledge of some quality assurance. If you've seen some of my videos, you might know what I'm talking about. And I appreciate quality much like the Star Trek Voyager show. So who am I? I'm a current CLA LabVIEW champion. I've been around in LabVIEW in different areas. This was me presenting at ASMS, which is a mass spectrometry society for publications and drug discovery. I was a bit of a thrill seeker, so I used to do a lot of tandem jumps. This was me jumping at 18,000 feet in Titusville, Florida. Learn that you don't scream on the way down. It's very dry, and it will dry out your mouth, and you can't breathe, and you'll have a panic attack in the air like I did. 3-minute free fall, that's a lot to panic about. I'm also a wandering traveler, so me and my wife went on a great cruise, saw Italy, the Colosseum, had a lot of good time there. You may have seen some videos that I've been producing from the NI Connect 2024, perhaps from 2023 with the Programming Essentials. Last year pre-presenting with Q and the How, and doing the video editing as well for last year. Luckily, I have someone else this year, so I can take a bit of a breather and have some time to present. I first got involved in the editing back in 2019 with the CLA Summit, and I just keep trying to elevate that code quality so that we can bring more folks into LabVIEW at a more professional level. It's much easier to do. Some of this was brought through a TV show that I helped produce the past 5 years called Donation Outdoors. It goes local as well as nationally on the Sportsman's Channel. This is likely my last year to do it, so I have built enough capital to carry on my equipment. It takes 6 months and by weekends away to do the NI Connect stuff is about 2 to 3 months out of my weekends, so I'm always working 60 hours a week. But I love y'all, and I want to contribute to the community, so that's how I'm trying to elevate. Hopefully you've all been watching. I'm going to explain a little bit of quality, different issues that have been through the years. Since 2000, 2001, I was offered a job at Raytheon. I turned it down to go to PVI Systems because I love LabVIEW. I saw it in college, and I thought it was really cool. So we helped to develop a lot of different end-face inspection tooling for fiber optics, which is more commercial off-the-shelf software. Backplane inspection systems in a variety of different enclosures with some motorized enclosures. Solar panel inspection with multi-cameras, dealing with a lot of different calibrations, end-of-the-line inspections. That was a 230 megapixel image that we had inspected in under 15 seconds for about 30 different types of defects. So that was really cool. Ring seal inspection, this was a rotating tabletop. Inspecting, coming on 2 different inspection stations, a laser height, and doing some part sorting. That was probably about a 4-month job for us. Another example, a medical staple inspection. They have to qualify what they do when they recalibrate medical staples. So they want to make sure undercrimp, overcrimp, a bunch of that, so they end up burning off, we'll call it fake flesh, like Mythbusters. And they throw the staples in here, it vibes, it pulls down. We had a shallow depth of focus and being able to basically make a 3D model and rotate it in dimensional space and use iMac to make those measurements. So it was a lot of fun. With PVI Systems, they had another sister company called Sound Analytics. So they took the IP that was in the life sciences and bio and went into COTS for Discovery Quant. This software was designed for mass spectrometers, a lot of HPLCs, a lot of different pumps, a lot of different novel algorithms. So we used LabVIEW to inherently pick from database, being able to design experiments, and basically run it through the mass spec to what I called getting a compound signature. Every compound breaks down into multiple molecules. This is a way to break it apart, novel algorithms to do saturation control, so it was much easier to detect. Once we can find that, we go to analyze. We start putting cocktails together, figuring out how much concentration things were. So did that for about 3 years. And it almost broke me because you get so obsessed with little features. Had a lot of partners on that. They ended up creating another company called FiberQA, where they want to take all their telecom and fiber inspection tooling that we had in-house for 10 years and go in a different direction. So we started creating new hardware because we didn't see a lot of microscopes. So we had ADX, 200, 400, and different fixtures that went involved in there. We started doing integrating cleaning with a desktop solution, and we already had a large solution inspecting about 700 ferrules in 50 minutes. So that was really cool. I think it was like 2,000 images. So that was a lot of fun to be able to work on that, design different software for different groups and ferrules and views and defects, and be able to do a lot of reporting. So we were trying to measure quality for end customer. We also had to create quality within the own software. I ended up leaving to try a different firm. I was done with contracting. I went into manufacturing, where I work with Neptune. They manufacture a lot of different meters, from residential to commercial to fire service. Each meter that goes inside your house needs to have a register to collect that reading, whether it was through magnets or a gear train, and then you might have different endpoints to have to connect to that with R900 radio, a cellular inspection point, and then you have to have something to read that. So you might have a gateway that sits on the telephone pole. You might have a LoRa gateway, which you heard earlier about the LoRa, which was interesting. You might have a mobile data collector, which you put in a garbage truck and just goes around the whole town. Or you might have a belt clip when you're in the inner city and you can't really get good Wi-Fi, right? So those are all different ways that we ended up pulling all that together with a team. So we had a team of about 7 people managing that. We had 4 different facilities, from PCB inspection to subassembly all the way to final production, dealing with V&V and production on the other side. We produced over 1.5 million of these units per year. Our group had over 30 million tests to manage every year with over 100 testers. It was quite challenging, but it was fun. I was with Testrack for about a year. I wanted to get out of the manufacturing, go back into contracting to deal more in framework design. So you've heard most of their framework between Task and HAL and a lot of their different partners. I focused on HAL quite a lot when I was there, trying to get it to public market, different training, trying to really stand it up and get it in a fashion that we could work well. So last year, you probably watched the presentation with record and playback. We could automatically take the data from the HAL, export to test stand scripts. It was really cool. Worked on a millimeter wave application as well for last year at NI Connect. A lot of fun with TMY Tech. But now I'm here with DMC. So I've been with them for about a year, and the biggest project I've been working on is the NASA BOLE project, which I'm going to dive into, which is a lot of what spawned what I'm working on for the quality for that project. So the services, they have quite a lot. It's not just LabVIEW. They do PLC, embedded, and a lot of different services that try to make this whole NASA project a lot easier for us. But a lot of this stems from the different compliance levels that we have to adhere to. Almost all the projects have different levels of quality, whether it's on the power side, UL, ISO. They all have different compliance requirements of different quality that we have to try to stand up for. So a lot of this stems from going further and going into the Center of Excellence. I've heard it bring about quite a lot. Is everyone familiar with Center of Excellence? Not too many. Website's there. Please go ahead and check it out. If you don't know how to design your coding standards, this is going to get you there. This is going to try to do that audit for you. Most contractors that I've been with have been a Center of Excellence. I know that Nancy knows a lot about it too. So go ahead and pick on her and meet with her in the back. I know that there'll be a lot of different information. So they really have the 3 pillars: engineering good software, engage in community learning, and ensure technical leadership. I certainly value that, and NASA on this project was interesting to adhere. So we were working on the space launch system for the booster obsolescence life extension, basically the boosters on the side of the rocket. We all do life design, we all do waterfall design. I'm not going to go into that too much, but there is a bit of a life cycle with certain gates that we had to do in accordance with the compliance. So your typical requirements design, PDR, CDR. We are currently in development, slowly approaching FAT within the next month. So a lot of what I'm showing is just kind of what we have at the moment, and we're currently refining it, constantly innovating. It's never static. We're always listening to our developers, to the people who have to make reports, and try to innovate new solutions around that. So part of that came out of Chris Cellino's design, and there's going to be a webinar probably in about 2 months that we want to try to focus a lot on what is the quality management system that we've designed that will help automate a lot of us no matter what language you're in. So we're dealing with C, embedded, FPGA, Python, LabVIEW. The system that we're trying to create will adopt to all of that. So we have a library of inputs. We have what we call our RTM, or Requirements Traceability Matrix. It's basically a board that exists on Monday. It's very similar to Jira. Most of those requirements are from the customer, and they're not testable requirements. So we have to create derived requirements upon a parent requirement to be able to get it in a testable state. So that's one key feature that's different in what most people deal with requirements. We also tie that into what we call our Scrum board. I'm going to go into that. Most of our designs are in Confluence. So before we do any coding, we have to actually write the design in Confluence, share what that is, understand what that test design is so that we can start beginning coding. All of this basically boils down into what we call our requirements coverage table, which is also in Confluence and a little bit in Get, a little bit in Monday. This RCT is a summary that we can use to try to generate what are we doing for requirements coverage. When it does all of the pulling of that information from all the different tools that we have, we can easily create a report at any time. It's going to show us all of our Korea jobs that have been built and submitted as artifacts from GitLab. We also have PyTest, which is integrated, which is also going as an artifact, all using the JSON or I forget what that term was, but does anybody know? No. Okay, doesn't matter. It's a format of JSON to be able to collaborate all of that data. Requirements, how many are passing, how many are failing, automated tests. There's also more detail in the actual report between showing the name of the requirement, the parent, derived, ID, a whole bunch of stuff. I'm not going to get too much into that because I know that there's going to be a separate webinar on that. But it's the main purpose of why we're trying to drive all this quality, is to get this report, produce monthly metrics, nightly builds, and be able to run this report and figure out where we stand. So what I'm going to try to focus on is the developer template, which is basically a scrum of any feature that we're trying to develop in LabVIEW or Python. Most of this is developed in Monday with multiple links to allow our developers to easily progress in the development cycle on a single feature. So I'm going to not go to every single one. I'm going to focus on a bunch of these, some of the tools that we were able to create. So one of the development tools is preparing things for handoff. You're going to develop code. These are not necessarily done in order. You're kind of able to do what you will. Some people want to take the test approach first, then develop code. We're not locking you into any kind of gating order here. If you do develop the code, you want to develop links to the requirements. Since the requirements are basically a web link, we're going to put a bookmark called REQ, and the tag date is going to actually be the website that's going to go to the actual requirement, because it's going to have all the detail there. So it makes tracking the requirement a lot easier. We also have to track what we call safety critical items, which is a feature of the NASA documentation and compliance, where we have to build in a safety critical tag. We have to make sure that we draw a frame around what is actually safety critical. And it's easier to look at the VI icon, and we wrap that in a red border color. We also have to integrate with Veristand. You can add the same level of requirements into the description fields of sequences, stims, logging profiles, sysdefs, and projects. So no matter where this requirement may be, there's ways to do it in Python, in Veristand, in LabVIEW. So it became a much easier way to track. We built some software to help track some of this requirement documentation. So the requirements themselves on the Mondays have all of this actual details from origins, dependencies, what are the efforts in order to build this feature, what are other software-derived requirements, as well as ATP boards and design. So developers are going to add this link into their VIs and the safety critical. This software will help validate and build reports. It has a Monday API toolkit that we built internally. We run it through CI to help build RTG coverage, automating the JSON reports, as well as during our functional and quality self-assessments and quality coverage reports. We launch it through a tools menu. We can go to settings, we can override what the source is, whether it's by a folder or a project or it's a Veristan sequence, figure out what our report is, enable a bunch of stuff. We hit generate, we see some progress on the bottom, and it generates us some requirements. These are not the actual requirements, but I do like Tommy Two-Tone. To generate the key requirements, we've got the keys, we've got the descriptions, we've got links to files, we've got different views that we can look at safety critical. There's also viewing by file, so if we want to understand what requirements are attached to each file, we can do that as well. We also have ATP included, so as you're building your set of requirements and descriptions, what is each ATP element that is linked to that requirement will also show up, trying to connect all this together in one view. There's filtering, so up on the top, you can type in test or try to filter what your requirement is, and it really makes it easy for the developers to figure out what's missing. And again, this is also called via CLI, so they would build the RTG report. If we want to be interactive with the developers, we build the WYSIWYG report, so if they want to do any kind of exporting, they have that ability. We also build what we call a test approach. Test approach is quite unique in that we all know we have to build manual tests and unit tests, but it's typically difficult for our developers to build that in a meaningful way. So before we go off and build that, we build a test approach, or what we call a test strategy, where it goes through all of these different options. On the left, it gives you all this information. Off to the right, you're going to go ahead and build all this information in an essay format so that you can review it and team lead it before you actually start writing all of this information, all these unit tests and all these manual tests. It's quite extensive. Let's see if I can bring it up. It's not showing on the monitor. This is pulled from our Confluence example. Some instructions on how to do it, a very quick summary table. Getting requirements, oh, that looked like the same piece. Am I going in the right direction? Yes. So there's a checklist that we end up writing, some guides, and off to the left is where we start showing the test approach information. Understanding what are different design techniques. We don't really know what they're going to be designing. This could be in LabVIEW and Python, whatever, so we need to keep it abstract. On the right, we're going to be showing our Shirey experience, software and hardware integration. As you're starting to integrate, what are lessons learned? What are some things that you found out? Again, on the left, test coverage and prioritization, creating effective test cases. Why do you want to write the test code? What are different types of tests that you might want to consider on every phase off to the right? How are you going to integrate all these types of tests for alpha? We call I/O checkout. That's when we actually get the hardware in. We write tests to validate the hardware that we get in, the enclosures, the wiring. Can the hardware actually do what it's advertised to do before we start going into FAT? Factory acceptance test, a lot more different types of tests. Great, I can write a test. Well, how do I detect it actually passes? You need to consider that when you're writing your tests. Once we write the test, we have different feedback, different action items. We can keep track of all of our checklists all within this one little Confluence page. And this is developed per feature. And we have a different review. Pretty much every 2 weeks we go out and we start reviewing some of this test approach. So hopefully you found some of that valuable. There we are. So once we have the test approach and it's been reviewed, now we can go ahead and start adding documentation to the code, which is a process I think we all don't like, right? And I think that's a lot due to the process. So when you're trying to add documentation, you have to go to the front panel, you have to go to the block diagram, hit Control-I, select the documentation tab, hit Edit, type all the stuff that I want, hit OK and save, and then keep repeating that for every VI. That's kind of exhausting. It gets worse. When you want to start editing your control objects, go to the front panel, right-click the visible control, go to Properties, go to Documentation, add the documentation, and keep doing that over and over and over. That's difficult when you have to document everything, right? And this is when we become Homer Simpson, we all walk away. We try to avoid that. So I created some new tooling. It's Shirey Studios VIA Plus. I submitted it last week to vipm.io, but it's not approved yet. So as soon as it is. So this is the current link for it. A lot of the software I'm going to show in demos today are going to come from here. So this is the wiki home from Bitbucket. So you have a choice. Everyone in the audience, after this, there may not be turning back. So you can take the blue pill. We can keep PowerPointing. And you can stay in your IDE, or we can take the red pill. You stay here with me, and I show you how deep this development can go. Red pill? Blue pill? You want the red one? Okay. All right. We'll do a demo for you. And it looks like my VM is locked. All right, so I wanted to show some of the tooling that allows us to do documentation for VI descriptions a little bit easier. And this is the tool I might be able to try to do live Zoom. Hey, it works. We're going to start picking a project, and we have two different ways we can run it. We can run it in a VI analyzer task, which is its main purpose, or we can perform a tooling task. We're going to do tooling. We've got different options to choose different types of containers, whether you're loading a project, a library, packed class, maybe a specific folder, maybe only one VI, VI colors, or I can get anything that's active in memory. This allows me to easily scope what I want to use and filter on. We also tend to want to exclude dependencies, targets, and anything in the program files folder. I don't care about third-party product. I don't want that to load. I don't want to deal with that with anything in my tooling. I just want my class. So let's go ahead and load the class. All right, we show a list over here off to the right. It looks like everything that I need. This little button will reset all the paths, so if I don't want to carry that over. I'm going to go to next. Here next is my filtering option. This allows me the ability to exclude particular build folders. You saw in Sam's presentation, it's hard to exclude my unit test, my CI test, other folders. This allows you the ability to remove that from your tooling automatically. Much easier to save all this so I can exclude my CI test, my additional test, my templates, my builds, anything else that I'm doing. If I want to hard code specific folder paths that I just don't want in my folder, if I want to ignore certain bookmarks or maybe only keep certain bookmarks, this is a very useful tool. And here I don't think I have too much to filter. If I click filter off to the right, I am going to get all of the unique bookmarks, which is a way so that if I wanted to understand a subpanel, oh, I just want to review that, I can come over here and just say keep my one subpanel as that block, and I can make tooling on just that one VI. So there's a lot of cool things that I can here do in the filtering. Now we're at the finalizing step of tools. I've provided 3 different ones. We're going to go through them all, but right now we're going to look at VI descriptions. And I can run this tool. It's a little bit big. Yeah, I think I'm going to turn off live Zoom. What does this do? All of my VIs here are on the left. And I can easily navigate with plus backwards. I can show descriptions. Maybe I just want the ones that are empty. I can filter my view. You can also look at not Windows Start, the block diagram, and I can start going into all of my views and stay in that view. Or I can easily just hit Control E and navigate between the two. There it is. I can see the icon. I can see if there's conflicts with my class, its version, its description, its path on disk. Front panel, there's different edit connector pane. This just basically allows you to edit what is required, recommended, or optional. So if I wanted to change what that looks like from required to recommended, hit apply. It can easily see that the icon got changed. There's some shortcuts here, shows you forward, back, a bunch of different stuff there. We can set entrancy, so if I want to change the single VI to a different level of entrancy, I can do that. I can see its reentrant, I can see its shared clone. If I want to easily click bold, if I want to create italics, if I want to insert that it's a shared clone, if on the block diagram I didn't like that wire, I can do wire this better. And I can do an insert, and I have a Boolean with that bookmark, and I can now tell did I actually finish it or not. So you can attach bookmarks to labels, which is a very useful feature. You can change the bookmark here as well. You can do thresholding. So if you have a requirement on a certain number of characters within your descriptions, this is a way to edit it and check for that. So if you're trying to do VI analyzer tools without having to rerun the tool again, this is a way to do that. And then save all changes, we've got that part. I think that's all I really wanted to show on this part. There is another tool called the edit control descriptions. This tool will try to fetch all of the type defs first, because we all know we want to edit type defs first. Most of these are not relatively complex, so I'm trying to go into one that isn't. So part of a class is we know the cluster, we have the string. We can look at each individual part of the actual VI. So over here we have the VI, we have the actual control. We have VIs which might give us a little bit more depth on some of these controls, like this individual alarm. So on this visible panel, is my control visible? Is it a class? Is it a strict type def? What is the actual label and caption? I can start clicking into each individual element of my cluster and start documenting at that level. You can see the description. Is it on? Is my caption there? What class is it? What pane is it? Where is it located? Do I have key navigation? Descriptions. We've got the same character and word descriptions counting. We've got back and next. So we also have the shortcuts, so I can quickly navigate between different controls using the tab navigation quickly to navigate between descriptions. We got different filters. Maybe I want to only edit visible. I don't care about type defs or anything that's empty. I've just reduced my list to go and edit descriptions. So it's an environment that if you do have to do this level of documentation, it's all in one spot. You can see exactly what you're doing. If there's a non-visible control, this is an easy way to get to that. Any quick questions? Good, because I'm going to have lots more demos. Try and close that. Close that, and we'll get back to the next one. All right, so we took the red pill. So let's see if we can go on to the next part. All right, so we've documented our code. Now we're going to start developing the test code and the ATP. We're going to be developing unit tests and manual tests. And yes, Lisa, we want standardized testing, or at least documentation on how to do so. So we built in documentation to help our developers to figure out where do all these things go in the root of the project. We've defined where does the CI test go per feature in a very large project. Where do we put our additional tests from the manual test, the hardware integration test, the proof of concept tests. These are the folders that we don't want VI analyze to analyze, right? They're all just going to work for us. We might have different templates and utilities. We standardized on Karaya, so we built a bunch of template examples so that you can pull from this, do save as, and start going really quickly. This is a module unit test, so as we're building specific modules which are similar to DQMH, we have multiple unit test cases where you want to change your state and understand how all that works within your class, so you can modify and move along. We've got module load unit tests. We know that most of we're following the factory pattern. We've got different settings for each class. We want to load them from different areas. We want to change the child. We want to exercise that. Make sure you build a good, strong unit test for that. We also have RT testing, so that creates lots of different wrinkles in how we deploy. We do have some examples for that. We call it our step unit testing. We also build manual tests. Not everything can be done easily in a unit test. We look at ROI. Does the ROI pay off to write this as a unit test? Is it something that we even need or can do in CI? If it is, great, let's do it. When we can't, we have to do manual tests. A lot of UI integration is difficult to do, so you're going to have to do manual testing. You might have editor integration, being able to change settings, widgets, hardware. All of these things are going to have to be manual, and you have to write different tests for that. We do add the RTM hyperlinks that we talked about before, so we're going to add in the requirement with the website link that all gets JSON to go to the JUnit to create that RTG report for us automatically. So once we build the tests, we actually have to, produce them, right? And we get in the cycle of, I fixed it, I didn't fix it, I got to keep going back and forth. So the CI, I'm going to look at the results. So that runs in a continuous cycle. One of the challenges for Bole was trying to figure out how do we get a list of VIs that were ran on our UI tests, on our manual tests, on the actual built product. How many have used Desktop Execution Trace Toolkit? How many people find it very useful? How many people would love to have it scripted? Okay, a couple. So what I ended up doing was I wrapped the DEET into these VIs to basically start a session and stop a session, where I don't have to have this open. I don't want to have this tool open and have my users click start and stop and modify. I can't do that in CI. It's not going to work. So we have start and stop, and we can turn off and off the service by using the DEET equals true, or I turn it to be false and it won't actually execute. Or if I'm doing CI, I can't use symbols unless I'm using a project, so I have to have a way to kick off CI to not use symbols. There's also a pre-build action which sets some ignore tags. I'll get a little bit into that. When we run DEET, we want to understand what do we actually log? What do we want to consider as dead code? So we use the settings where we can block particular folders, whether it's in the development space or the executable space, as well as specific folder paths that we want to ignore or all the third party. I might have a short demo. Are y'all interested? Okay. Let's see if I can go to my DEET folder, open the project. The wonderful load dialog. Still waiting. Uh-oh.
Maybe you don't have a demo.
We'll see. It all worked a minute ago. This is the joy of doing live demos. Oh, we're missing something, so maybe I can't run it. Oh, yeah, it always fails in front of people. Let's see if the top level will go ahead and run. Compile, you can do it. Oh, we're broken. We might have to change it, but I will at least show some of the code and some of the examples. So part of the debt is that we want a result file to be generated, and we have to start this before everything is able to run. We want to append a date time, and I do have the option to log some date times. Off to the right, the very last thing that we do is stop. The idea is that I can run this as a full development, I can run this as an executable, and I can get this log in terms of what was actually executed and understand what code was actually ran, and that's the purpose of what I'm trying to do. The other tool is I can get some start and stop times that might be in a specific environment, which is also useful. Being that I can't run it, I don't know what else to do. I might have some example reports. Nope, I deleted them. Darn it. All right, well, I can show another tool. Another thing that the debt doesn't really do is understanding what source actually is. It's very difficult to figure out what paths are in an executable environment when you're translating between different targets in different areas. So what we're doing in development is also something for a replacement or a real-time execution trace toolkit, which can also be called in a desktop execution trace toolkit. We define a source folder, we define a source list file as a result. Basically, I want to generate a build and understand what is in my actual build. I have multiple projects that I'm going to be building. I'm dealing with Veristan, I'm dealing with RT, I'm dealing with LabVIEW. There's a lot of stacks, so we can also integrate to the solution builder as well. What we're actually trying to do is add a VI onto each diagram. So we can pick what that VI is. We can add or enable it. We're basically using a stable structure. If we don't like it, we can disable it. So we can do a different type of build, or we might want to remove it completely. And we can set up different ignore paths as well. So we hit generate and go. What it's going to do is it's going to add this little script down here in the corner. The idea is that it's got a bookmark, conditional disable. I am adding an async call and forget so that every VI, it's only going to call this the first time, so less overload. And because pathing is such a bear to compare in runtime, I add a GUID. So part of what this does, it adds the script, but it also adds a unique GUID per VI. So when I build the actual log, out of the output, I can compare the GUID, not just the path. So now it's much easier. So when this actually runs, it's essentially going to save just a GUID file. Just all I care about is did it run. I can add more meta information in that GUID file should I want, but it's going to save it on the actual target of the RT or on the desktop. So what happens when you run the tool, it adds it, it builds a source log. I'm going to be able to show that file in just a short minute. Actually, let's see if it'll load now. Hey, it opened on the right screen. So we've got a project. I know my target. I know my build. Like I said, in Veristan, we're doing multiple of these. I can understand its VI path. It's good. When you're trying to track dead code, parents and classes are difficult. So I need to understand, is this VI a must override? Is the parent saying it's must override? Where is the parent override? Where's the GUID to that? Because if you're creating an abstract class, it's never going to be called. It's still in memory, so it never executed. So there has to be some magic and some logic to understand what is dead code and what you consider truth. So part of this is building this document so that we can understand after runtime, when we do our compares, what is actually dead or not against source, against the build, what's going to be built. Is there anything else I want to talk about that one? No, not yet. Again, it's something in development. I did hear from Neosoft has a really cool feature for RT that I'm going to be looking into for syslog that might be a little bit better for us. We all love our functional code reviews. I think many of us are doing it in a similar way and standard way, creating merge requests or pull requests, doing markdown checklists. So we have a separate checklist for functional, or what we call FCR. It involves a functional checklist as well as a quality checklist. When you start merging, we never try to close the branch. We give the opportunity at any point in time, you can push it to main, just don't close the main branch. When you do modify, or if you are going to close that branch, you have to run a QCR, which is at the very end. Or if you are modifying code and you don't need to go through functional again, we're going to go a QSA, which is called a quality self-assessment, which is pretty much just a VI analyzer type of script that we run. So I can try to share some of what these operations look like, at least in a merge request here. It's kind of a lot, but I'm sure most of you have seen similar documentation. I won't go into it in too much etiquette. I will put it up for download. But design verification checks, we are running certain tests. We are doing code reviews on user interfaces specifically, mentioning any kind of rework, how to do the rework, and do we think things are complete. And we also look at quality for the inspection of your builds, for particular icons in public. We're also doing different checks for Veristand, different documentation inspection, and then you can open up a quality review. So we're trying to give all these steps in a markdown template to get the information and be able to document that information before you actually have to run the merge. So who's ready for QA? Yay, it's a dumpster fire. When we think we're all done, we're going to kick off the quality code review, and this is where a lot of the issues usually tend to crop up. We have a very similar template. This template is not marked down, but it's going to be in Confluence. Similar to what we saw with the test approach template, we're going to try to link everything in Confluence or repos or ATPs so we have one-stop shop of understanding where everything is. We're going to have prerequisites, trying to figure out where everything is, providing feedback in a quality manner. And then most of these are checklists. They didn't print off in the PDF, but they're going to be checkboxes that you end up running. We have a LabVIEW, quality standards. We have requirements that we want to inspect with all the tooling that you saw before with the bookmark manager and Veristand manager. Safety requirements. There's different checklists for Veristand from the engine, the system explorer. We actually want to build it. We want to check documentation on the Veristand to making sure channels and descriptions are all in place. We want to make sure that we'll actually build. Veristand, yeah, these are all the different areas in that area. We did have some Python checks in here, but I think I took them out. Anything that can't be checked with VI Analyzer has to be put here. Most of the low priority things I haven't been able to write yet. So there was a bunch of checklists in there. So once we do the checklist, there might be some action items. They might fix it. Then I have to actually re-inspect what they actually fixed and go forward from there. Very basic template, but just simply having one has added a lot of value. Can't necessarily show the actual website being an entire project. But hey, we all trust engineers, right? Yeah. So I'm going to show some of the tooling that I built for doing specifically on quality code reviews. We do have a Veristand checker. Looks like I only have 10 minutes, so I'm going to have to race through some of this. So we're all going to enter this cautiously like dodgeball. The Veristand SDF is basically a way to report the engine so that we can get documentation. It can go into MS Word, Excel, or Tab delimited. It's basically documenting the interface and how they would use it. The channels, the sections, the aliases, which are basically your variables. You can also export it for validation. So we want to make sure that all the documentation is right. We're not using improper words. That we have enough descriptions in our words. We're not using illegal characters. This is reusing the spell check that's in VIA Analyzer, so it's a win-win. You can also create your own project dictionary so that if you have custom words, it's easily going to parse that out. So that saved us a lot of time to reviewing the Veristand side projects. There's also a build custom error. So as we're building up either packages or libraries of the full application, we want to understand what is all of our custom error codes. So do we want to attempt another demo? Yeah. All right. Hopefully I don't, like Homer, find all those bugs. Oh, we closed our VM again. All right. I think, if I'm correct, this is hard to do backwards. Build custom errors. I already loaded the project, so I can just run the tool under DMC for build custom error codes. This will load the active project. You pick which project you want. You can go to settings modes and add any error wrapper, any custom error wrapper that you will have or design. You might have specific ones. DMC's got their own error handling toolkit. There's an error cluster from error code. We also have a styles toolkit. There might be other ones that are internal, so you can easily add, remove, or edit. All that I require is I need to know the name of the VI. You can mark it as active. What is the label of what the actual error code is so that I can search for that? What is the custom error path, caller VI path, a whole bunch of different cool little options. I'm not going to go into that too much. The idea is that I want to start this build. So for that little tiny class, it's going to load over 8,000 VIs and try to find where all those VIs are in memory. And I think I wanted to go to the offline help viewer since I know I don't have internet. And I just want to understand what are my custom error code ranges. If I can type correctly. That looks like the right one. Nice. So I can see all the different custom error ranges that I should be within. So I use this knowledge to try to figure out, did we set error codes that are outside that boundaries? Let's see where we're at. Looks like we're still building. Oh, we're almost done. OK. So now it's going to retrieve all the VI callers. It's going to try to dynamically figure out where all those wires and all those constants are, and I get a list. This is sorted by error code, and I marked a few in red that don't fall within that actual error code range. So I can double-click on my Vim. It shows me the VI. It shows me the error code. I know it's actually accurate. There are some other ones that end up going kind of far. So it will follow the wire and go all the way across and try to find that constant no matter where it's at. So it's a very useful tool when you want to start building APIs and try to not have overlapping error codes across your entire design. So this was a really useful tool for that. Once you do build it, you can export it. There's multiple formats as usual. I think text, semi-Excel, CSV. Yep, good. I had an error. Let's continue. That's pretty much the build error code. So it helps us across multiple projects to at least help us document what those are. And we'll go to the slide deck. So we were able to do that demo. All right. Going to go back to the VIA Plus. I don't have as much time as I'd like, so I may end up skipping this presentation on this part, mainly because of time. So there's some other tools I want to show. Part of the VIA Plus core is that you click this button for the project settings. And part of what the drive was is that there's different priorities in VI Analyzer, which we want to take advantage of. Anything that's in a high priority is going to affect functionality, or it's something that is a strict coding guideline that we want all code to adhere to. We want that always at 100%. This can be run in CI. We always want this. Where it starts to get delineated is where it gets arbitrary. Certain projects want to enhance quality. If you're not doing compliance, we wanted different thresholds. So something that's of a normal priority is maybe something that's in the standard guideline, but it's not a nuisance, but it may be something that you get to over time. Low quality or low priority are going to be very low nuanced things like wires and things that annoy us all. It's almost hard to get perfect code. So part of what we're trying to do here is by file or by project, giving the scope of where we want these thresholds to be so that it doesn't make the code worse, or we don't have to work on the things that don't matter, depending on the level of compliance that we want to do. Was there other things in there? There was. We're going to go through scripting. I'll show you a tool on that later. There's also history, so as you're using the tool, you can export all of this. There is the import and export tool, so that when you define all of this for your individual repo, you export it. It will include your scripts, your history, so you can leave that as a VIA Plus file in your root and easily bring this up for repo, and it just makes the whole experience a lot easier. You can predefine pretty much everything for your developers. So we'll close that. You can pick multiple projects. Again, choose your task. We're going to choose the VI Analyze. Click Next. We can add multiple configurations, the same VI configurations that we had before. We always have 3. We design our CI script so that that's only going to run our high priority. We have our quality. That's basically everything that's normal and low. And then we also have full. It's up to the developer to choose which ones they want to do. They click load, everything loads on the side. You can see what priority it is, what's the maximum failures, the test name, the description. You can export this in multiple ways. You can share what these tests are in MS Excel, MS Word, HTML tables, and you can choose different priorities to be able to do the reporting so that you can let your developers know how they need to pass these tests. From here, we did the load. I think it's just a different view. Yeah, it's just, so we're going to select the full one. Click Next. We saw how we can load projects before. We saw how we can load. We'll click Next. We saw how filtering works. I'm not going to go over that one. We go to this screen, and it basically calls the same VI Analyzer toolkit. We hit Analyze. It will show down below and show us the progress. You can always hit Abort at any time. You can get this wonderful view, which our developers love. They can click. They can figure out what's wrong. Thank you for 5. And what's unique here is that we can see the different priorities at a project level as well as a VI level. That allows us the quick way to double-click on these files, go to that file, create the fix, and understand which are the areas to focus on. And you can see the different thresholds there as well. Exporting, you get the same reports, ASCII, HTML, RSL, which is what you load back in, as well as the list box. Scripts, I do want to show some of this because Gordon Ramsay said so. Part of the, let me go ahead and close this real quick. A lot of folks tend to have issues when they want to automate fixing, much like you saw in Blue. Blue is going to work on everything. The JCrawler will likely fix the things, the only things that it needs to, but there are certain things that they just may not want to fix or just want to do something. So there's a tooling task. We'll load our library. I only got 4 minutes, but we'll get to it. We're not going to do any filtering scripts. We've got a bunch of different scripts, and basically they act on the entire thing that I've loaded in memory. So if I want to do certain things on a UI, I want to do certain things on a class, this gives me all that quick ability. If I want to change bookmarks, for example, I can get all of my bookmarks. I can get it to do. I can change all of this to done if I could type correctly. I don't want to be done, but I'm almost done. We'll find them. It will do it. So it says done. Is that what I wanted? Do a refresh. Oh, because I'm using tags. So we end up splitting bookmarks into 2 parts. So semicolon is the status of a bookmark. So that's what this is doing here. So it only changed the beginning part, the actual tag. So we have a different bookmark manager that will understand the status of a tag versus the actual description, which is a different way to use bookmarks. So that's a really cool tool. There's a whole bunch of other ones in here. Move primary to monitor. I don't want all my code on some other screen. Put it all here. Couple other ones you can all check out. Globals, auto debug, a whole bunch of other cool stuff. I did want to get to the other demo, which this thing is almost too big for me. Under tooling, there is a report descriptions tool. This, I want it to be in Antidoc, but I only had 2 weeks to do it, so this is what I came up with. When you're doing documentation, there's different levels for developer versus product or user. You can make your own file. There's a multitude of settings here for the documentation, each different area that you might want to represent, user interfaces, dialogues, controls. There's different levels that you might want to include. See, projects, user interfaces. You can pick what level of documentation you want. Interfaces, classes get very unique because there's a lot of different areas that we might want to document, whether it's class private data, a list of my controls, list of my methods, my set and get accessors, libraries, and scope. Maybe I only want to report particular scopes inside my documentation. Controls or type defs. Do I want to control just the list, the whole views, and different options? This is a really cool view so that we can enable in a document reviews, making it easier if I want to spot auto error handling, inlining, separating code compiled. I'm not going to click report because it's going to take too long, but I believe I have some documentation pre-done. This is a developer view. It does go to MS Word. Again, if I had more time, I really want this to go into Antidoc. You can use your own template. It builds your table of contents for you. You can look at your project description, memory, conditional disable structures, user interfaces. It breaks down everything into a really convenient view. The name, I get the hyperlink. I know it's shared retention. Is it in line? Am I doing auto error handling? How is it compiled? How many revisions? Memory, its complexity, its icon, its description, how many unique bookmarks are in this. This is what I call a developer view. You can change all this for the product view. Should you have an API and you just want to build documentation to document your API, this will do all of that for you. Front panels, GUIs, it breaks down every single message. Let me go over here to classes. That's usually what we're most interested in. In a class, we get the properties. We can understand its inheritance, interfaces, as well as its private data, and it nestles even deeper than just the class private data of a DVR. I go inside a DVR and show you all that information, whether it's a queue, a notifier, or a DVR. So it really paints the picture. Similarly, I think we have a little bit different here. What's the scope, dispatch types, reentrancy types, and different compiling. And I think I'm out of time. That's it. Thank you.